Welcome to this session. In this session, we are going to prove that matrices are either Mission or skew Mission. And we start by problem 1 to prove that the matrix A is summation. And then in problem 2, to show that the matrix given is skew Mission. So the first one, so solution. For problem 1, we need to show that A is equals to A raised power theta, i.e. A is the same as the transpose of the conjugate matrix A. Now, this question, A is given as 1 minus I, 2, 1 plus I, 3, I, 2 minus I, 0. So which implies that conjugate of A will be given by 1 will be 1, this will be 1 plus I, 2 remains to be 2, 1 minus I, 3 remains to be 3, I will be negative I, this will be 2 remains 2, minus I becomes I, 0 remains 0. Now, A power theta, which is the conjugate of the transpose of the conjugate of A, will be, now we transpose this matrix, so we'll have 1, 1 plus I, 2, then second row becomes the second column, 1 minus I, 3 minus I, third row becomes the third column, 2 I, 0. And clearly, you see this is the same matrix as A given. So therefore, since A power theta is equals to A, then A is a mission. So that's how we prove that. Problem 2, we need to show that A power theta is equals to negative A. That's the proof that A is skew symmetric. So in this case, A is given by, for problem 2, minus I, 3 plus 2I, minus 2 minus I, and then minus 3 plus 2I, 0, 3 minus 4I, 2 minus I, minus 3 minus 4I, and then minus 2I. This is the A matrix. And you see, this implies that the conjugate of this matrix is I, 3 minus 2I, minus 2 plus I, minus 3 minus 2I, 0, 3 plus 4I, this is 2, plus I minus 3 plus 4I minus 20 plus 2I. Then this means A power theta, which is the same as the transpose of the conjugate of A, will be, now transposing this matrix, we get I 3 minus 2I minus 2 plus I minus 3 minus 2I 0 3 plus 4I 2 plus I minus 3 plus 4I 2I. And you see, we can write this matrix as, if I write negative outside, or let me just factor negative for each element. So negative 1I, and then I say negative 1 into, this will be 3 plus 2I, and then this will be negative 1. So I have negative 2 minus I, and then here I write minus 1 minus 3, and then plus 2I, and then I write negative 1 times 0, negative 1, 3 minus 3 minus 4I, and then negative 1 into 2 minus I, negative 1 into minus 3 minus 4I, negative 1 into minus 2I. When now, because every element has a negative, then can factor out that negative 1. So I have negative I, and then 3 plus 2I minus 2 minus I, and then this is minus 3 plus 2I, 0 minus 3 minus 4I, 2 minus I, minus 3 minus 4I, and then I remember when I factored those, so this will be plus, so that this will be negative, negative, and then plus. So this is positive. And then here I have minus 2I. And you see, let's write this one properly. So this is 3. So this was negative 1 into 3, then minus 4I. So here I have negative minus 2. And then here I have 3 minus 4I. You see, these elements of matrix A are the same elements we have here. So these get the same as saying negative of A matrix. I remember this was the same as A power theta. So which implies A power theta is equals to negative A, hence A is skew emission matrix. So that's how we prove that a given matrix is emission or skew emission. And then a theorem that the matrix B power theta AB is Hermitian or skew Hermitian according to A being Hermitian or skew Hermitian. So that means that if A is Hermitian, then the matrix B power theta AB is Hermitian. If A is skew Hermitian, then B power theta AB is skew Hermitian. And then another result for any square matrix A, for any square matrix, if A times A power theta is an identity matrix, then A power theta times A is an identity matrix. That if A times A power theta is identity, then if you reverse the order of multiplication, you still get back the identity matrix. Thank you.